Hello again. In this video I'm going to be going over the pickle TryHackMe room. This room was created by John Hammond and it covers the Python module called pickle. Yeah, so let's get started. I already ran an nmap scan. So if you just do nmap on the IP address, it does not reply. But if you do checkpn, meaning you do not ping the box, it does reply. So just from here we can assume that there is a firewall blocking our pings, and we can see that there are 3 ports that are open. Port 20 and 21 are both FTP, reserved for FTP, and we have port 22, which is SSH. Okay, so what we can do is try to connect to FTP to see if anonymous login is allowed. FTP here. It's asking us for a username. Let's say anonymous. Anonymous or password as well. And as you can see, the login was successful. I do LA. So we have 2 files. We have test.txt and we have a hidden file which is creds. So let's get both. Let's get .creds. Good. Let's exit from here. I did not create a ticket. Let's move into TryHackMe pickle and more the hidden file as well. Okay. Let's cat test.txt. So it's just saying FTP the test file. It's got nothing interesting for us. Let's cat the creds file, and it looks like binary data. What we can do is copy all of this and head on over to CyberChef to try to see where it resolves to. Let's look for binary from binary, and this looks like human readable stuff, but it still is not 100% readable. So after a while, after doing some research and stuff, this room it covers the pickle module. And actually, fun fact, pickle, I think John was inspired by a challenge from the website pythonchallenges.com. There was a challenge called pickle, and it was the same thing. It just covered the Python pickle module vulnerability. So essentially what the pickle module is all about, let me just erase this. It just serializes and deserializes data, because when you want to transfer data over a network, that data needs to be converted to bytes or bits. So yeah, that's when it comes to Python, that's the pickle module. The pickle module does that for you. I'm sorry, I'm not explaining this very well, but yeah, essentially, in order to store like programming languages objects on disk, or just to transfer them on network, they need to be converted into bits and bytes. So this process of converting data and objects into bits and bytes is called serialization. Yeah, so in Python it's called pickling and unpickling data. I hope it does make sense for you. So all of this just to say that this is pickled data. So let's save this output to a file. Let's name it file.txt. Okay. save, go back here. So we move file.txt here. Good. ls. So we have file.txt here. Now let's create a simple Python script. Let's name it payload.py. Doesn't matter. Now we import the pickle module, and let's say the file, or let's not name it the same thing. Peak is equal to open file.txt, and in this case, because when it comes to opening a file that contains pickled data, it needs to be opened in read binary mode, not just the read only mode. Okay, we can say pickled data is equal to peak, or pickle.load, or is it .dump? I think it's load, not so sure. Print pickled data. So pickle.load is just gonna unserialize this serialized file or data or object, this serialized stuff. This pickle.load is just the function to unpickle that data. Let's python 3 payload.py. Okay, now it's a little bit more readable. So we have, it looks like a sequence. So SSH pass, like it's a password for SSH, pass 15, user 1, 25, SSH pass. So what we can do is create another, or just use the same script and add some stuff to it that will essentially, because this looks like a key to me, and this looks like a value. So what we can do is, instead of printing this data, we can use it and convert it to a dictionary, so that we can iterate over each of these values as keys. And the way dictionaries work is, when you specify a key, it gives you the value. So we can use an empty string and add each value so that we can have the original username and password back. So let's do just that. Let's delete this, and let's have an empty string here, and password empty as well. So let's say for I in range, because we had SSH pass 7 times. Just remember this. So username plus equals, and I did not transform this into pickling is equal to dic, transform this into dictionary. Now we can say pickling SSH pass right. Now in the password, if I remember correctly, it was 28 times that it was randomized. So password plus equals, we'll just add the same thing again. This time it's gonna be SSH pass instead. User, right. So let's print the username and print the password. Okay, so we do have some credentials now in order. So you could have just actually I don't think you could have. It's just too difficult. Okay. You essentially have to go G H. I don't have the patience for that, but I think it's easier to do this with Python. But anyways, let's nano creds.text and copy this here. Good. Now we can try to SSH with these credentials. Gherkin, it's a different IP. Yes. Pickles all around the world. Nice, we are in. We are the Gherkin user. And we do have a script here. Usually Python scripts are denoted by this extension .py, but in this case it's .pyc, which means this is a compiled Python script. So we can let me just go here, and we can just get this script and try to decompile it to see what it has inside of it. Just the name of okay. CP. Actually, very graciously, my terminal remembers this command. So we're just getting this Python script here, as denoted by this dot at the end. Just one. It's asking for this user's password. Okay. Let's cat cmd. As you can see, it's compiled. There is actually a tool to decompile it in the command line. I do not have it installed, so I just looked for one online. So Python decompile online, just easier actually. It does decompile Python as well. This is the extension that we have, pyc cmd, and this is the Python script but decompiled. So we are importing some modules, and we do see something that's interesting to us. We have username and password, long to bytes. This long to bytes function imported from this crypto.util.number module. It just takes integers and it converts them into bytes. Essentially, this is what it does. So we have other functions that we're defining here, and just to make it simple, if our credentials are correct, there's this main function that starts a web server in all local interfaces, basically on the local host on this port. We can try it through 7321. Let's try to connect to that port. It was 7321, and it's asking us for a username. Let's say John. Wrong credentials. In the script, where is wrong credentials? It's just printing this self.send, return true, none, self.send successfully logged in. So it's checking if we are not logged in, it's giving it this. If we are logged in, it's just doing this, basically. Yeah. So we can do is nano test.py, and we'll just have Python print those usernames. And okay, let's go back here, the username and password. Invalid syntax. Okay. So dumb, I'm expecting some output, but I'm not printing anything. Oh, not 2 bytes. So we have the username and the password printed for us. Let's echo dill, never a dull moment, creds.txt. So we can save them. And now we'll try to connect again to that same port, only this time we have some credentials to work with. Never a dull moment. My bad. Successfully logged in. So who am I? We are the dill user. I have clear. This is a very restrictive terminal. Yeah, let's just look for, because the first time when I was doing this box, I tried, for example, to ping sudo tcp dump. Let's see if we're gonna receive any. Let me just config 0. This is my IP. Let's try to ping my local machine. Let's just leave it there, actually. So as you can see, we are not receiving any ICMP packets. If you remember, our first nmap scan did not give us any information back, because maybe there is a firewall blocking ping, but now we can see that we are not allowed to ping from inside the machine, my own local machine here. So what I did was just enumerate the box, and since we are the dill user, we can access our own SSH credentials or keys. Sorry, we can go to .ssh, we can type it well, and look for his key. We can copy this, go back here, kill this listener because it's useless for us. Nano ID. Copy this here, save, give it 600 permissions so that it does work and SSH does not yell at us. We are done with this. We can exit from here, exit, and try to connect to SSH as dill. And we are in. It did work. This is a much better terminal, much better shell. So this is user.txt. Let's do sudo pickle. So we can run this with a sudo command. Let's try it actually to see what it does. And we don't need a password, which is convenient because we don't have this user's password. We only have his SSH key. Pickle farm, grow something on the pickle farm to grow when it's expecting some input. Let's say John. This does not grow on the pickle farm. Let's say failed to decode base64. Okay. So since this room is about the pickle module vulnerability, essentially since we are pickling data so that we can, for example, transfer it over the network, once it needs to be depickled or unpickled, if the developer, for example, does not or just unpickles any data, we can just give it a malicious base64 pickled data that just, for example, gives us a reverse shell or spawns just a bash shell, for example, whatever you want, for example. So that's just basically it in this case. That's what we need to exploit. Let's go here and cd home pickle, create our payload, just exit from here, go here, and nano payload .py. I already had this, it's fine. Import the same module, and we're gonna need base64 because we need to encode data, and the OS module so that we can spawn a bash shell. We'll have a class in this case. Let's name it rev ever, and this class needs the reduce function so that pickle knows how to pickle this data. Self, which is the instance of the class. This is just if you go to the pickle module documentation, you would know, you could read about why we are doing this, but essentially it needs to be like this, because if you don't give it this reduce method, pickle will not know how to pickle this data, and it needs to return a tuples. Well, let's just say that our command is equal to binbash, which is very simple. Because when I was going through the box, I spent some time trying to get a reverse shell. For some reason, it did not work for me. I'm sure it's just because I was doing something wrong, but spawning a shell there actually worked for me, so I'm gonna go with that again. Why would I do something else this time? No. Let's return os.system using the system module, and this needs to be tuples. Good. And now we can say stuff is equal to, I think it's pickle.dumps, pickle.loads, unpickles data, and pickle.dump pickles data. Serialize the object. .dump and dump our class. Right, and now let's print. Now base64 encoded, b64 encode stuff. Right, this looks good to me. Let's save and let's Python 3 payload. telling me that I have a syntax error. It's because it did not have space and dump missing required argument file. I think it's .dumps. Not really sure. Let's try again. Okay. It's .dumps and not dump. Let's try to grow this time. Failed. Can't get attribute ref on module main built-in. Failed to execute script. Let's try SH, maybe. I'm just gonna troubleshoot a little. Maybe I'm doing something. Gonna try it and see if this works. Wait, before I do this, let me just go here and look for proof of concept Python pickle vulnerability. Let me just look for the error code again. File, line 18, can't get attribute ref on module name. Don't remember the correct syntax for this, I'm not sure. With no quotes. What's wrong? This is equal again. It's seems to be broken. What? I have no idea why it's erroring out. It's the same thing, but yeah, let's give this a shot, I guess. Just waiting for the machine to respond. It's not seem to be responding again. Okay, so it did work. I'm not sure. Let's get root text. What? Let's put space here. There's a space in the beginning. So this is the root flag. Yeah, thank you for watching and good luck. Goodbye.